Hi, today we're going to talk about scatter plots. So what I have up on my screen are actually a whole bunch of scatter plots, and we're going to go talk about a few of them. So, for example, let's take a look at this first one. This is a scatter plot because the dots are not forming like a perfect line as if we were using a linear graph, but the dots are kind of just scattered. Okay, we can also see that in a few of these graphs as we look around. The dots are kind of scattered around. Now, as we've looked at these three, you might have noticed that, yeah, they're kind of scattered, but they're like scattered in kind of the same direction. Like in these, they're scattered kind of going up, right? They're kind of scattered going up. Whereas these are they're scattered, but they're going down as they're being scattered around. We call that, here and there's a picture here, we call that correlation. So for example, if they're scattered going up, then we call that a positive correlation. If they're scattered going down, like we saw earlier, then we call that a negative correlation. If they're scattered in a pattern that is not just kind of going up or down, so like for example in this corner, we call this non-linear correlation. Okay, so see how it's definitely got a pattern, but it's not a linear pattern, so it's not like straight going up or down. The pattern, it's a curve. Those are kind of the three types of correlation: positive linear correlation, meaning it's going up; negative linear correlation, meaning it's going down; and nonlinear correlation, meaning there's some kind of pattern, but it's not a straight line. Then the last kind is no correlation whatsoever. So see, if you look at this, there's no correlation. It's just a whole bunch of dots scattered around. That's scatter plots. Now, for scatter plots to be especially useful, sometimes we like to create a line of best fit. So, line of best fit. Let me show you what that would look like. Now, we can tell that a scatter plot, right, the dots are kind of scattered around, so a line of best fit is actually not going to be a line that touches every single point. It's just going to be a line that kind of seems to follow the trend of the data. So see, as this is drawn here, it doesn't touch every single line, but the line is going in a positive direction, kind of following the same trend as the data. Okay, notice on this one, the line's going down. It's kind of right centered in the middle of all the data, but we can't, make it touch every single point because that doesn't work for a scatter plot. Okay, and we call that a line of best fit, where the line just fits the data the best that it can. Now we can make an equation for this line if we want to, using slope-intercept form, y equals mx plus b. So let's say we have this line, and yeah, okay, it's not exactly going to touch every single point, but it's following the trend of the data. Well, then we can find the y-intercept, which is 1, 2, 2.5. So I'd say the y-intercept is 2.5. And we can find a slope. We find a couple points. Now, these happen to be like points that are from the scatter plot and on the graph as well. That's great. But if you don't have those, you just find close enough points as you possibly could. Like maybe here's close and maybe here is close. And so then from that, we could find our slope. So from here, we go 1, 2, 3, 4, 1, 2, 3, 4, which makes it a slope of 1. So it'd be y equals 1x, or just y equals x, plus 2.5. So what we've learned is scatter plots have correlation, positive, negative, nonlinear, and no correlation. And you can make a line of best fit, which is a linear line, a straight line that just kind of shows or follows along the trend of the data. Thanks, bye.